In class, we were given an activity where we had to code or decode DNA of snorks. And what you see here is one of those DNA strands. And I've highlighted two portions, one in yellow, one in blue. I am going to run through the steps for both the yellow and blue strands, and then you will complete those steps for the remaining portion of the DNA strand. So starting with this yellow portion of the DNA strand, in order to figure out what mRNA would go with that, we have to decide what pairs with A, what pairs with C. So remember, we say apples in a tree, chips with guacamole, but in mRNA or in any type of RNA, we're not allowed to have a tree, so we replace the tree with the letter U for uracil. So A pairs with T, but remember, apples in a tree, A pairs with T, but we have to replace that T with a U, so that A pairs with U here. Chips with guacamole, C pairs with G. Another C pairs with G. A G pairs with C. A G pairs with C. A T pairs with A. A T pairs with A. An A pairs with U. And a T pairs with A. Again, we use the term or the mnemonic apples in the tree, chips with guacamole to remember our base pairs. Continuing down from that, to make the tRNA that matches with this RNA strand, we again have to say what pairs with what. So U pairs with what, G pairs with what. And again, we use that same mnemonic. So U pairs with A, G pairs with C, G pairs with C, C pairs with D, C pairs with D, A pairs with U, A pairs with U, U pairs with A pairs with U. So that is the tRNA that goes with the mRNA strand that we coded for using the original yellow DNA sequence. For the amino acids, we must use an amino acid chart. That is found on the second page of the activity. So this is a modified amino acid chart. We have made it a little bit simpler. We've taken out the names of the amino acids and actually removed some from the list so that it's less confusing. Any blank spaces you should not land in. If you land in a blank space, you want to check your code. So we'll go down to our mRNA sequence. We use our mRNA to find the codon. So the first codon we have, and we count these in threes, a group of 3 of those nucleotides is a codon. So UGG is the first codon we're going to use. Again, that comes from the mRNA sequence. And if we come up to our amino acid chart and we look for UGG, the first letter is found here on the left column. Second letter is found across the top. Third letter is found down the right-hand side. And again, we were looking for UGG. So U tells me I need to stay in this first region here. I'm not allowed to move anywhere down below into any of these rows because the first letter of those amino acids will not be a U. G being the second letter, I come up here, and second letter is this very last column here, so that means I need to stay in this column, remember, in this first section, because the first letter needs to be a U. And the last letter that we had was G, so that tells me this final box here. So we're looking for this amino acid labeled 20. And we come down to the amino acid, and we'll label it 20. Now I'm going to put a dash in between so that I can remember that's just the first 3 nucleotides. The second 3 are C, C, A. So I'm going to go back up to my amino acid chart. First letter being C tells me to stay in this section. Second letter being C tells me to stay in this column. And then third letter being, what was it? C, C, A. So third letter tells me to be in this box right here, which is 11. So I'll put an 11, and again, I'll put a dash. The final 3 nucleotides I see are A, U, A. Again, I'll come up to the top. A being the first letter, so I'll stay in this section here. U being the second letter tells me this column, but remember I have to stay down in this section. And A being the last letter tells me this row, so that tells me 13 is the number of that amino acid. Then I'm going to put these slashes in here to tell me that I'm separating the different segments of the DNA strand. So I'm moving on to this blue segment. In the blue segment, I'm going to say AGC. What does that match up with? So A pairs with U, C pairs with C, C pairs with C. And I've got CGA. So C pairs with G, G pairs with C, A pairs with U. And then GGG, G pairs with C, G pairs with C, G pairs with C. Again, I put a slash to separate it from the rest of the chart. To convert that into tRNA, again, I'm looking for those pairs. So U pairs with A, C pairs with B, G pairs with C, G pairs with C, C pairs with G, U pairs with A, C pairs with G, C pairs with G, C pairs with G. So I go through the strand. Again, to get my amino acids, I have to use the mRNA strand. So I'm starting with the first three. So UCG, I come up here, UCG tells me 16. The next group of three is GCU, GCU is 2. And the last three is CCC. So I'll come up and I'll find CCC is 5. Now we have both of these traits or amino acids ready, and we're going to go compare those to the trait chart. And the trait chart is probably the easiest portion. I'm looking for 20, 11, 13. So I scroll up, and I'm looking 20, 11, 13, and here it is. 20, 11, 13 tells me that the creature I will draw will be hairless. So I will mark down hairless. And the second portion is 16 to 5. So as I go above, I'll look 16 to 5 tells me this creature will have 4 legs. So once I have coded the rest of the strand, I found the mRNA, the tRNA, the amino acids, and all of the traits, you will draw a creature using the traits that you found. So your creature will be hairless and have 4 legs, and it might have slanted eyes, a tail, a round head, depending on the amino acids that you get from your DNA sequence.